Okay, so today we will start with the Spark streaming. Okay, so when we discussed about the Spark ecosystem, ecosystem. Okay. So we just initially we started with the Spark Core API, which is basically the already transformation and action. Then we actually worked on the Spark SQL, right? So now the next library or component in Spark ecosystem is a Spark streaming. So till now, what we worked is uh, the APIs which is used for batch processing. Okay, so that's a thing you need to understand before getting into the Spark streaming. So whatever we worked, either in terms of identity transformation or action and the Spark SQL. So these two components meant for batch processing. Okay, so if you have a huge amount of data and you want to run the very complex queries and generate insight out of it, so these two APIs can be used. Okay, there are some scenarios where as soon as the data gets generated from the source, so it can be any source which generates events in a shorter span of time. You can think of as a sensors in a smart city, or it can be any sensor which emits data, or even can be application, any application which generates the data in a short span of time. So it can be of any the online transaction application, like it can be any banking transaction, it can be or any payment transaction which we make on the e-commerce sites, right? So if you want to retrieve, catch, if you want to consume those data, and if you want to process this data in a shorter span of time to generate insight, or it can be like fraudulent detection, or those things can be done using a Spark streaming. So Spark streaming is uh, basically used for that kind of scenarios. Okay, so in definition, so in Spark, right? In Spark, when we say Spark streaming, there are two categories. Okay, one is D-stream based Spark streaming, or it called traditional Spark streaming, which was introduced, I think Spark 1.3 or maybe the earlier version. Okay, so till Spark uh, spill, sorry, till Spark 1.6 or 2.0, they were using this D-stream based Spark streaming. Okay, so the concept is same. So basically, there will be a source which generates events, and we write a Spark streaming application which consumes the source data, and we do some operation and write it into sync. When we say sync, it's basically a target. Okay, so this is the high level overview. But internally, how the data we are going to consume and how we are going to process using the underlying abstraction APIs differs, right? So in batch API, what we did, so when we read a file, right? So if it is unstructured data, we can actually read it as a RDD. Okay, so basically you can load it into RDD and we can do some operation. So basically RDD there, RDD acts as a abstraction for your data. Okay, so your data is abstracted on the RDD, then you perform some operation using the RDD. Similarly, when you get a stream of data from the sources, what abstraction or you can think of as a uh, data type you are going to use hold that stream of data. Okay, so when the Spark was introduced streaming, so they used something called D streams. Even now it is available. So when you go to the Spark streaming documentation, so you see here, you're able to see my screen.
Yeah.
So if you go to this documentation, you see structure streaming and also you see Spark streaming D stream based. So even now, some people, the earlier systems which are there built, they are not migrated. They are still using the Spark streaming, which is D stream based. So basically, internally the data structure is different. Okay. So D stream is similar like RDD. Okay, so it is very raw API. It's not meant for it, or maybe out of box. It will not give you structure. Means you have a stream of data coming in a structure format. You cannot actually create a data frame from that. So you have again a D stream which will have a sequence of RDDs. Then you need to convert that D stream which consists of sequence of RDD into data frame, and then you work on it. So that's how D stream will work. So we'll just uh, try to understand what is Spark streaming in detail. So Spark streaming is an extension of core Spark API that enables scalable, high throughput, fault tolerant stream processing of live data streams. Okay, so here it can be scalable. Yes, we working on the cluster computing framework. It provides scalability and high throughput. So this is the important. So basically, it's used for basically high throughput applications. Anyway, fault tolerant is there because internally D stream is nothing but a sequence of RDD. If it is something fails, it can regenerate from the lineage. Spark streaming provides high-level abstraction called discretized stream or called D stream, which represents continuous stream of data. Okay, and the D stream can be created either from input source, from the input stream from sources such as Kafka, Kinesis, or by applying the high-level operations on the other D stream. So similar like RDD, so you can create a D stream from any sources which generates a stream of data, or it can be if once you have a D stream, if you perform some operation, then you get a new D stream. So it's like similar like RDD because internally it's RDD only. Okay, so internally D stream is a represented as a sequence of RDD. Okay, so so I will show you the simple example in this documentation. So example, let's go on the stream. Okay, so here when what you need to do when we use D stream based Spark streaming. Okay, so you need to create a Spark context object. Okay, so this was earlier this is very earlier system. So those time there is no Spark session. So those days basically Spark context. Now Spark context is a part of your Spark session. So when you want to use a D stream based, you need to import the Spark context API, and then you need to create a streaming context. So you need to create a Spark context as well as you need to create a streaming context, object for streaming context. So first we are creating a Spark context by passing the master URL and the app name. and then creating a streaming context. Streaming context, the input is basically you need to pass the Spark context object, and this is for batch interval, which is in I think milliseconds. Okay, so once you provide, so now using so Spark streaming context as a set of receivers. Okay, so when we say receivers, so it can read from some sources like which is mentioned here. Say example, it can read from Kafka, it can read from Flume, it can read from S3 or HDFS, Kinesis, Twitter, and there is something called socket, which is a TCP/IP port. Okay, so how we can read it from a TCP/IP port is basically if you have a TCP port open, so if you publish some data to that TCP port, we can consume using the socket stream data source. Okay, and what you get is basically a D stream. So that's what we discussed. When how do you create a D stream? Basically, when you consume from some data source. So once you have a D stream, you can apply a transformation already has a transformation in action. D stream also has a transformation, which is similar to RDD transformation. So flat map. When you do flat map, what you are going to do? You are going to iterate each element in this D stream. So you can actually each element you just split by a space separator. You get a is basically this is a kind of word count program. You pass some string, you split by space separator, you get a words. Then you uh, apply map transformation, assign a counter, and then apply a reduce by key and do the uh, sum based on a grouped words, then print it. Right. So it's so when you want to start a net socket like a TCP port, and if you want to publish some data, you can use this command nc-lk. So we are going to use it in our Spark structure streaming program. I will give you a new demo. And so when you run this program, this is a streaming program, and the whatever it is written above this some 10 lines of code from here, this and this and this and this one and this. So those 10 lines of code are kept in the network word count program, and so basically it's taking input where so basically when you we are consuming from the net socket, right? So you need to pass um, the which server and the port number. So that is taking as an input from the front end, and then so this is how you get output. So this is one terminal. We are publishing like you said type netcat -lk and double line. Say example you pass hello world. So when you read this as line, so we know it's a word count program. You just break with space and apply a counter. Okay, so this is similar like our uh, the batch API word count. The only difference is you actually process the stream of data, not the just reading from uh, any particular file. You are not reading from the static source. That's important. This is not this data is this data is not read from the static source. Instead, it is read from the stream source, which is in this case socket. Socket is basically a stream. Just a minute, I'm getting one call. I'm sorry. So the source basically here we read from the not the static data source. We read from the streaming data source. Any question?
No, Pari. It's okay.
All right. So basically, what is the difference between batch processing and stream processing? So basically, what we discussed already. So basically, batch process, the data will be sitting in any data source, right? When we apply the processing or query, we apply on the entire data set most of the time. In the streaming, it is be mostly based on the uh, respective batch interval data or the rolling time window. Data size, generally batch processing data will be huge. This will be a micro batch or the individual records. So what a Spark streaming says is basically they work on a micro batch. So particular time interval, say example, every based on the batch interval you pass in this example you saw, basically for every 1 millisecond, I think 1 second, so batch interval is set as 1 second here. So every 1 second, whatever the data which is consumed from the socket, so it will be processed. So here it is mostly in the seconds or milliseconds. In batch, it will be in minutes or hours. So analyze, you can do complex analytics using a batch processing. For stream processing, it is more of simple aggregate functions or rolling metrics. Framework, out of box, the frameworks available for batch processing, Spark Query API, which is basically RDDs or data frames. Also MapReduce is there for the batch processing. For stream processing, we have Spark streaming, and we have other framework or library called Strong, which can also do the stream processing. Okay, now we'll come back to the Spark structure streaming. Okay, so basically, what was advantage you get a Spark structure streaming over D stream is in the D stream. Basically, what you see is basically I told you when you read from any stream source, you get a D stream. Stream source. What you get is a D stream. So D stream is basically it's kind of a raw data structure. So what you see is more of like collection of values. So you need to actually make a structure. It is not a structured. So we saw like basically even if you pass, so example, if this here I'm just passing some free text. Say example, instead I'm passing a JSON structure, or it can be a comma separator. Say example, I'm passing a employee record in a comma separator. Again, you get in a D stream individual record as a like one record which is consist of particular employee record in a comma separator. Then you need to convert that into structure by splitting comma separator, and then you need to create that convert that D stream into data frame that you have to do manually. Okay, manually means programmatically you need to do it. So example, somewhere they would have done. Yeah. So if we have a you have this D stream. So if you want to convert this data frame, what you need to do is you need to uh, iterate over each RDD. Okay. Then the RDD basically D stream is nothing but you can think of as a sequence of RDD. So you take RDD, okay, and then use a map transformation and convert into a row. Okay, so basically each element into row, Once you have a RDD of rows, you can create a data frame. So Spark dot create data frame of RDD of rows. Then once you get a data frame, you can create a views and apply the Spark SQL. This is how we can do when use a traditional Spark streaming or D-stream based Spark streaming. Okay, so out of box you are not having any API which provides you uh, uh, the structured format, right? That's a lack. That's where it's lacking in the D-stream based Spark streaming. Okay, so when it comes to Spark structure streaming, so what it is going to give is whichever the data source it is reading, so it is going to give you the structured data structure. When you say structured data structure, basically you get data frame. So in a traditional Spark streaming, you get a D stream as a output when you consume from the source. Here you are going to get a data frame. So basically, it is the unbounded data frame. Okay, so unbounded data table, they call it data frame. Basically, what you get is a data frame. Okay, so structure streaming is a scalable and fault tolerant stream processing engine built on the Spark SQL engine. So it is basically internally using a Spark SQL engine. So you can express your streaming computation same way you express the batch computation of the static data. So in a Spark SQL, what we do is, example, if I'm reading from CSV file, right? So I will show you the example. So this is the simple Spark SQL or this. Okay. So what is this simple PySpark program? What I'm doing is I'm just creating a Spark session object. I have a file which is a transaction detail.csv. Okay, so you can think of as this is the data, right? So basically, this is the structured data. So we have a columns and we have the rows which for the entire every columns we have. So this is a comma separated data. Okay, CSV file, right? So if you have a structured data, we can actually use the Spark data source API, spark.read. You can say CSV or you can say format of CSV and load of that path. If you give the path of your CSV file, then you get a data frame, right? So then you can perform some operation or aggregation on the data frame. So your Spark structure streaming is going to be almost same style. Okay, so just you can use the same link to join if this disconnects. So when we use Spark structure streaming, it is going to be same style of this format only. It is not going to be much difference. We'll show you in the next example. So that's what this says. Basically, you express your streaming computation the same way you express the batch computation on the static data. The Spark SQL engine will take care of running it incrementally, continuously, and updating the final result as a stream of data continues to arrive. Okay. So basically, you will have a user input and you will have a query, and you will get a result table. Whenever whatever query you perform, you finally will get a result. So every here also we have a batch interval. This is at a time interval t1. This is the input data you got. you apply some query, and you get a result. Again, at a T2, basically you will have data which is consumed D1, D2, T1, T2. So basically here you can actually apply the computation on entire data set, or you can actually do the incremental data, whichever that is, we can actually decide. Okay, so basically you get every time interval, you get data and you process and you get the result. Okay, so before going to this, okay, so basically when it comes to Spark success streaming, you are going to read it from the sources, right? So let's understand before getting into the more details, okay, or maybe, okay, I will give you this one. Okay, so you need to understand these concepts when we read about Spark success streaming. One is sources. Okay, so from which source you are going to consume the data? That's basically sources. So it can be this socket, which is a DCP port, or it can be a file stream. If you are going to stream your files, which is continuously, somebody, if say some system is continuously pushing data to the particular directory in a regular interval, say example every 5 seconds or 10 seconds. So how do you read those files in a streaming fashion? Basically, that's what file source is nothing but. And Kafka is basically one of the most popular stream source when we use Spark success streaming. And you need to understand what is sync. So basically, this wherever data is getting generated, basically those are the sources, right? So how we are going to consume the data from those sources, basically sources. Sync, how we are going to write the data into particular target. Target sync is nothing but target. Okay, so for now you can ignore this part, and you need to understand what is source, what is sync, and what is the output modes. This is going to be little important. So whenever you receive data from these sources, okay, so I told you this, you from the stream data stream, the data will keep appending to the one unbounded table. So internally, it gets all the data, right? So whether you every batch interval, you want to process the data on entire data set, which is retrieved from the over the period of time, various time interval. You want to process entire data set, or you want to process only the updated one, or if you want to process only the new data. So that depends based on the what type of output mode you use. Okay, so this is, I will tell you in very in detail. We'll just see with the example. So these are the three things first initially you need to understand: what is source, sync, and output modes. Then we'll go back to this checkpoint, window operation, and the join operation and the stuff. Okay, so let's understand the first source. Okay, before that I'll show you one more. Okay. Okay, so you can actually go to this the programming guide, and you can go to the the structure streaming. And these are the 4 out-of-box supported sources, right? The Spark structure streaming can read from only these sources. Okay. One is file source, Kafka source. File source basically, if you have a particular directory where you have this type of file formats, so text, CSV, JSON, ORC, Parquet, Parquet. These can be read in streaming fashion. So you have out-of-box APIs, and then you have other source called Kafka source. So basically, if you have a Kafka, Kafka is nothing but is a publish subscribe messaging system. It's just a messaging system where different application publish the data to the Kafka topic. When you say topic, basically it's a persistence layer in a Kafka, and other application can consume it. So it's more of a data exchange platform. Okay, so that is supported in the Spark structure streaming. And apart from this, these two are for mostly testing purpose. So socket stores, where you have a TCP port, you publish some data and read it. And another is the rate source to generate some sample data. So these are the 4 sources available in a Spark structure streaming. So first we are going to see the socket stream. Okay, so we have only 1 minute left, sorry, 1.5 minutes. Just we'll disconnect this and use the same link to connect, and we'll see this socket source. Okay, so you will get actually you'll get understanding of really what I'm talking about. Okay, so let's disconnect and connect with the same link.